Okay, now I want to show you a nice little toy I made here in Desmos to sort of help you visualize and calculate what's going on with approximating areas using Riemann sums. This is the function we used last time. F of x is 8 minus 1/2 x squared. We wanted to find the area underneath that from x equals -2 to x equals 4, and we used three little pieces. We made a stair-step function that had three kind of plateaus to it. So what this lets you do is I can change the function or a or b or just the number of pieces n, and it will update the graphic, and then also here calculate what the approximate area is. So for example, if I try n equals 6, then I get an updated picture here. We have a new approximate area of 36.25. And well, let me just kind of go back. If I just kind of drag this around, then I see that as n gets larger and larger, I can kind of watch the area down here to see what happens. Now for a small number of n values, there are some features that are kind of useful. What I've marked down here in red are these points that are the midpoint of each piece, and then their corresponding point on the graph up above them. But when you start getting to large n values, that gets to be a little bit busy. So if you go down here and click on this folder, you can turn off that part of it. It'll still show the shading of the area that we're actually finding. And so if I drag this all the way over to say n equals 100, well, now the picture is becoming almost indistinguishable from the actual graph itself. It looks like the area is maybe approaching 36 exactly, which seems like kind of an unusual, kind of coincidence. But in any case, you can play around with this. If you wanted to, you could change the values of a and b. So I could find the area underneath a different kind of bit of this function. Or you could just completely change the function. You could do something like 2 plus sine of x. Maybe, now I have a function graph here. Can swing it around some more. Change n. And so here's an approximation of 2 plus sine of x by a stair-step function over this range here, and I get an approximate area of about 19.9. So you see, with computers, you can really do a pretty good job with this. In Desmos, it's kind of fun to just start updating this n value and poke at just how far Desmos will let you go. So watch the area really closely. 19.9 when n is 100. What about 1,000? Okay, maybe you saw there was a little bit of lag there just for a second, but it's still about 19.907. What about 10,000? Let's watch. Okay, well now it's given up drawing it. It says, no, that's too many things for me to draw. Sorry. But this is just a restriction that Desmos is sort of putting on us. In a programming language, you could actually sit down and do 10,000 or 100,000 sort of little pieces here. You would have to be kind of careful about some things, but it's possible to numerically integrate, sort of numerically approximate the area under a curve this way. Okay, well, I'm going to share this with you, and I hope you will all enjoy playing around with this toy.